All right, so good morning, ladies and gentlemen, and welcome to the Internet of Things Research Center Seminar 6. So I'm James Chen from Department of Power Mechanical Engineering, and today we have a two seminar. The first one will be offered by Professor Zong-Hong from National Taiwan University, and the second one will be by me. So let's welcome the first speaker, Professor Zong-Hong from National Taiwan University.
Thanks for Professor James the introduction. And actually my education background is from chemistry. So today I will introduce some emergent sensor at least. Okay, I try to propose to the whole world. It's very simple. It's just based on the simple content and separation. Then it can help you to identify or sense the many things. Okay, so you can consider this might be additional sensor to the like the robotics or something. Is nowadays they always just provide the imaging function, right? But you can consider in the future you will also want the robotics to have like the smelling, okay, the testing, and even the more the sensitive the touching the functions. Yeah. So today I will show you the potentials. Yeah. The phenomenon we use is based on the Triboelectric effect. Triboelectric effect, I believe we all learned this when we were the senior or the junior high school students. Okay, so it's very simple. Based on the two material contents separate, actually the surface charge will transfer. But in this maybe around the 200 years, actually there are no many the scientists. They try to study more clearly about the phenomenon. Okay, so nowadays maybe you will just feel the inconvenience, right, from the Triboelectric effect. Yeah. So how is the device? Okay, how is the phenomenon to bring into the device and how it works? Actually, it's very simple. It's also based on the two material contents separate. Okay, and then because of Triboelectric effect, actually the electron will transfer from one material to the other, okay? And then after they separate, because the charges on the insulator will remain for a while, so now they will form the charge the surface. So that also means they will create a potential difference. And then they will push the electron, right, transfer from the nearby the electron and to balance the potential difference, okay? Then, of course, if you put some the electrometer in the external circuit, you will measure the output the signal. So if you can periodically to push this the two material to contact, okay, and separate to this the cycle, actually this the device can provide you the continuous the output. So you can consider this device is very simple and easy to convert the mechanical the energy to the electrical the energy, okay? So except for the energy harvesting application, you can also consider this device is a cell power sensor, right? For example, if you apply the larger the force to the device, actually it will also respond the larger the output, okay? So you can directly to evaluate how is the external the force or the pressure applied on the device, and you will be able to know, right, based on the responding the signal, okay? And then if you have a capability, like me, education is the background, is a chemistry, so you can modify the surface. Actually, you can further to let the device become the chemical biosensor. Yeah. The reason is because I just mentioned the different material on the surface will always result in a different charge transfer. So that also means in final, you will also be able to measure the different the output from the device. Okay, so actually we have demonstrated for like the iron and some the molecule, even the some the microorganisms like the bacterial detection. So yeah, in some way you may consider this is very interesting. Yeah, but actually it also bring a very good sensitivity for essentially the application. Anyway, it's based on the why the different material will give you a different charge transfer and output is because they have different dielectric constant and work function. I would like to say this phenomenon is a very interesting science phenomenon, right? Because even nowadays, it's really not easy, right? You can search the paper and to understand the secret of the charge transfer, okay, during the content separation. And then if your background is from the engineering college, you are very good to design the device the structure. So that means you can just change the device structure and to harvest, okay, the different mechanical energy in the environment. For example, the wind energy, the water energy, many different kinds of energy. And if you were like me, okay, you are very good to do the surface the chemistry. You can also let the device become the chemical biosensor. Yeah. So actually, if you check the publication or the patent in the whole world, okay, for this the research, the numbers it really increased a lot. So the first case is very simple. It's when I was a postdoc in Georgia Tech. Okay. So at that time, I don't know too much about device, but I know very well about the chemistry. So I just modify the surface. The goal is the some the molecule with the carboxyl group, and we know the carboxyl group has a very high the binding affinity, okay, selectivity to the mercury ion, heavy metal ions. So I just consider before and after binding with the mercury ion, the output signal, okay, after the push the two material to contact, the output signal can be different. So you can see that from the output signal is true, okay. So like at that time we measure the current, you can see that before the catching the mercury ion, the device give you the output around the 60 the microamp. But for after the catching the mercury ion, the output decreased, okay, a lot. It's because comparing to the originally the carboxyl group, the mercury ion it has the less the tendency to transfer the electron to the other contact material surface. So this is the reason, okay, why you can see the output signal different. And then you can also just to have a very good selectivity, okay, because of the carboxyl group has a very good selectivity for the mercury ions. And then the other is at that time we also try to verify for the molecular detection, because before those the papers there is no one use this the phenomenon to develop sensor, okay. So in order to detect a catching molecule, okay, catching is anti-oxygen molecule. It's very abundant in the green tea or in the wine, the solutions. So we just use the TL to the nanomaterial. And we also measure before and after the binding with the catching the molecule. Will the output signal be different? So the answer is yes. So you can see that either for the output voltage and the current, after the binding with the catching the molecule on the surface, the output is always the enhanced. So you can see that for a different model, when you measure the output, right, some case they will show you a decreased output, some case will give you the increased output. The reason is that after binding with the target molecules, okay, some molecule will give the more capability, okay, for the surface and to give the more electron transfer to the other surface, okay. So this is also the interesting of the sensor. And then yeah, so however, okay, anyway, so you can consider this the device for energy harvesting, okay. For example, at that time, okay, like more than 10 years ago, just the one step, okay, we touch the device to work. The output the signal can directly turn on the 600 the commercial LEDs. So that means its output the voltage is larger than the 1000 volt, okay. And then you can also consider the content of material can be the liquid. So for example, if you want to harvest the raindrop or the water flowing the energy, right? The liquid, if you can directly use the liquid as a content of material, that will be more convenient. But anyway, and today I will show you, right, the two cases of the sensor. But what I just mentioned is based on the solid material content. And we know for the solid material content, it always might bring the problem of like the surface damage and the output signal is not stable, lost the problems. So to overcome this problem, so we just consider to use the solid and liquid content education. For example, the first case is that we just use the very simple device, okay, with the hydrophobic layer and to detect the iron in the sweat samples. So once this the device to touch, to content separate with your the tissue absorb with the sweat. If there is a different concentration of the the sodium chloride, then you will be able to detect a different signal. Okay, this is based on the solid and liquid content identification. And the mechanism is also same to the solid and solid content identification. Okay, so for example, when the water to contact with the material, the Triboelectric effect will also bring the surface charge to transfer. And after they separate, they will also create a charge the surface and also the potential difference. Then it will result electron transfer, okay, and to balance the potential difference through the external circuit. So you can consider if there are more ions in the water, so the ions will directly neutralize the generated charges on the surface. So that means the potential difference will be decreased. So of course you will measure a decreased output too, okay? But you can consider the case did not provide you the selectivity, okay? So maybe for some people, they want the selectivity. So in order to improve this concept, okay, later I will show you the more cases. So here I will just give a brief summary that for this technique, okay, Triboelectric Nanogenerator, many people consider for energy harvesting, okay, so they always hope the output can be larger is the better, right? But if you consider for the sensing, okay, no matter for the chemical, bio, or for maybe the tactile, the sensor, we always want the sensor, the size is smaller is the better, right? Because you can either to save the cost for the development of the sensor, or you can have a better resolution. So, but for this the purpose, you will need to have a very good capability to measure the small output, like a smaller than the mini ball, okay, the open circular voltage change. Especially nowadays, in most of our sensors, we use the single electrode mode. Okay, for most of the device, you will just consider it's the 2 electrode, right? But you never heard about a single electrode. Yeah, but for the convenience of the device, the fabrication, the single electrode mode is really very good. Okay, so but the single electrode mode is always bring like the background. Okay, the baseline of floating some problem. So you will need to match up a very good RC the circuit and to get a very stable output. Yeah. Anyway. So the first case is the same. We just touched the solution, the solid liquid. But this case, we also try to detect the catching. So we also use the TR to catch the catching and then touch the solution. So you can see we even try to verify on the different solution, okay? Because different solution also means different content material. It will also give the different electron transfer and result in the different output. So it's not the limit to only the water solution. So you can see that when detecting the more catching molecule, the output is increased gradually. Yeah, and then for a solid and liquid, this is the phenomenon to develop sensor. You can also overcome some problem from the solid and solid content education. For example, the humidity, right? Humidity is always a problem for this device. For example, in Taiwan, maybe sometimes it's easy it's always very hard to feel, right, the Triboelectric charges. This effect the phenomenon, right? But if you go to like the China, US, or Europe, right? Because the humidity is very low there, so it's very easy to feel the Triboelectric effect. Anyway, to use the solid and liquid, you can also overcome this problem. And then we try to detect the protein. Okay, so now we use another pro molecule is kind of the sugar, the mannose. Okay, so and then it can give you also the selectivity. So you can see that when catching the more protein on the surface, okay, the output signal is also increased. And then we also try to detect the bacteria. Okay, so and we also show you the selectivity for some specific strain of the bacteria. So you can consider when the sensors they mount especially in our lab, now we also have the robotic arm also, and the hand. So when you can consider for those sensor, when they integrate with those robotic arm or the hand, actually they will give the additional function of the imaging, okay, to the application. And then because the disadvantage of this device, okay, good is that it doesn't need the external power, but the bad news is that it needs mechanical energy. So how to let the mechanical energy from the environment and to trigger this the device work and let it feel is very naturally. We consider it's robust, right? Because we always want a robust like the human beings, right? And when a human beings, when you want to sense something, you always will quickly, right, to touch it and separate the surface. And we just consider this is a very naturally the motion, okay, for the robots to be like the humans. So especially in the future, you can also consider in many dangerous area, right? Robots definitely will help or replace the human beings to do the detection, to do the sensing the motions. So this is also what we think in this study. Okay. So we just integrate the sensor on the robotic finger, okay? And so when a robotic finger to touch the solution, it will tell you if there is something you want to detect in the solution. For example, the sample we demonstrate in this paper is the mercury ions, okay? So that means when the finger touch the solution, it will tell you if there is the mercury ion in the solution or not. And we also combine with a Bluetooth, the system, to trigger the finger to work and also transmit the detection the signal to your PC or the mobile phone. Yeah. So I will just quickly show you the result. Okay. So you can see that this is the system. Okay. So when you detect the solution, you can see only the mercury ion can result in the signal difference, because the material we modify on the sensor surface is only for the mercury ion detection, and for other the heavy metal ions, they cannot result in the signal difference. And then anyway, this original is with a video. So this is a module. Okay, now we develop. Okay, this is the Bluetooth system can help to trigger the robot hand to do the touching the motion, and then also can help to transmit the signal to the iPad. Okay, and we also verify this to the environmental sample. So now for this project, we combine the cell power concept, okay, to trigger the robotic hand to move and also transmit the signal. We use a thermoelectric generator module. So that means for this the whole module, if you put outside in the real environment, actually it can be charged by itself and then work for 3 or 4 hours per day. Yeah. So if you for other metal ion detection, you can also just easy to change the surface per molecule. And so and the most important is that for every of the detection heavy metal ion, it always can reach the drinking the water the requirement. I mean the detection the limit. Okay, so this sensor is not only new, but it can also give you a very good sensitivity. And then this is we collaborate with Professor Yang in the life science college. Is that he's very good at the drug, the simulation. Okay, like to find out some the drug is potential for some the disease. But you know, simulation cannot give you 100% sure the answer, right? So for our technique, we can help him to verify if the simulation result is really match up with the real sensing. I mean the surface, the molecular binding, the affinity, something like that. So actually, based on this, actually I'm not so confident with my technique in this research field, but he's very confident. So anyway, next year we will initiate start company. Yeah, just based on his yeah. Anyway, yeah. And yeah, so this is a result. Anyway, because of the time limit, so I will show another cases that in the smarter manufacturing, okay, the application, if you just want to easy to tell the material, like in this room, right, we may have the wood table or some the metal the door, something like that. Actually, you don't need to modify anything on the sensor surface. Just because, like I mentioned earlier, right? Actually, like our hand, when we touch the different material, actually the different material have different triboelectric effect. So it will give the different the transfer charges to your hand, or your hand will lose the number of the charges to the material. So that means just based on that, based on a simple touch and separate, even the robotic hand will be able to tell some of the very simple the composition of the materials. Okay, I will quickly show you the result. So so like in this paper, we try to detect like the let me see which one is. Okay, because the wall is too small. Like we detect some the fluorine-based the polymer or like the different metals. It gives you a different output the signal. Okay, so we also combine the very simple AI model. So that means it can help you, right? Be able to tell you, right? In the later when the robotic finger when you touch something, what is actual the composition of that material. Okay, so this is our concept. But of course, because it doesn't need any modification on the sensor surface. So I will say, even you combine with the AI, so maybe it can just tell you around, I think the 20 or the 30 on the material, the composition in the environment. If you want the signal, it's easy to be different. Yeah. Yeah, so this is our, and then we also want to see how precisely, or okay, how is the potential of the the phenomenon and can tell the composition or the molecular difference. Because I'm from chemistry, so in chemistry, of course, we have the many the fancy the equipment. Okay, is the costs their costs also are always very high. And they can help you to tell the molecule, right? The structure something. But is it possible we can just based on the touch and separate this the motion, the contact electrification, this the phenomenon, and then to tell the molecular structural difference. And the reason is yes. So in this paper, actually based on our result, is able to tell the more than the 10, the amino acid, the difference. We know the amino acid, they only have the very the smaller the difference is the functional group. But you can see that based on our technique, it can also help to differentiate the molecular structure. And the most interesting is that we even can tell the default and allophone. Default and allophone is just like you know the twins. Okay, they have the some the geometry the their molecule is the same, but they have the geometry the some functional group is in a different rotation. Yeah, but anyway, those are really very important for the drug the development. It's because for a drug, right? The reason is why it's so expensive is that if the default and allophone is the geometry is the different, the function will be totally different. Yeah. Yeah. So finally, actually in our lab, we also doing the other research. Okay, we are not only develop like those the physical sensors to detect the pressure and temperature, but we are also just to detect some the chemical or bios. Just as I introduced to you today, is based on the triboelectric and thermoelectric effect. Yeah. But we can also integrate those the two sensors, like to the robotics, right, or to the specific substrates like the textile, right. So nowadays, we in our lab we can also detect that the sway, right. Sway is more convenient and to the traditional blood detection, right, because blood detection is always immense detection. Okay, and then we can also develop some the circuit, the module and the APP to see how you will win the recovery without removing the dressing. Okay, it's also highly needed in the clinical the application. And in our lab, actually, the most well developed is the pressure sensor and the module. So if you integrate with the robots, right, it gives you like the touch the sensing the function. And if you just integrate with the insole, right, then it can help you to monitor your gate phase. So actually, the gate phase is very simple, but it's also important is for the patients, right? Or for the, we even do the personal identification. Actually, everyone you have different the working pose, the gate phase. Okay, so it can also help to do the personal identification. And we are also using this device to do some tissue engineering. Okay, but yeah, maybe you will not be interested a lot. But this is also very important, is because in this couple years, I believe I mean, Taiwan is very famous and very good with the semiconductor. But what will be the next industry? Okay, so I believe the bio really can bring another the chance. Yeah. Okay. So finally, thanks for all your attention. Yeah. Thank you.
Thank you, Professor Ling, for the interesting, excellent talk. And then I think we still have time to for 1 or 2 questions, right? So, any question from the audience? Yeah. Yeah, that.
So thank you, Professor, that this lecture is very interesting. You have mentioned that use the robot's hand to detect the substance in liquids, but I'm curious that if the flowability of this liquid that the river, and this will affect the sensitivity of this kind of detection.
Yeah, your question is really very good. It's because we have verified on the real sample in the environment. So for those samples, they don't have a problem. But you are right, for a long term, the monitoring, right? Like there might be some other objects, or maybe the strength for the water flowing is very strong. How will that affect our sensing the performance? So the answer is we did not verify yet, but I think that's a very good suggestion. Yeah.
And one more question is that is this detection can use for gas, air?
Yeah. Okay. So for this the research field, the first the material pair, okay, we try is the solid and solid material. Then is the solid liquid. And okay, actually when I proposed the concept of solid liquid in 2013, actually because the output is small, and at that time my advisor only care about the energy, so he doesn't feel this is very important. But actually the couple years he invest lots of the resource to, yeah. So he even published many in the Science Nature paper. But of course, at that time, 2013 is still new, so I don't have the chance. But what I try to say is that the direction is from solid and solid to a solid and liquid. And now in our lab, we are doing the liquid and liquid. Liquid and liquid is very difficult. It's how you can control the liquid content separate. Yeah, so that's difficult. And gas is also a very good candidate, but the problem for the gas is the density. It's always not high, right? So now for some papers, the only way you can do is that let the gas to absorb on the solid material surface first. Then you count it. You will still be able to get the different signal. So I think that's now that's the most possible way you can verify this the concept to the sensor. Yeah.
Thank
Thank
you.
you.
All right. Any more questions? There's no more question. Thanks, Professor Ling, again for the excellent talk. Thank you.